Today we'll discuss about Bernoulli differential equations. How can we classify Bernoulli differential equations? A Bernoulli differential equation looks like a linear differential equation except that on the right hand side, we can see that q as a function of x is multiplied by y raised to n. And a Bernoulli differential equation can be written in this form: derivative of y with respect to x plus p as a function of x times y equals q as a function of x times y raised to n, where n represents any constant. Now let's consider different values of n. If n is equal to 0, the equation reduces to a linear first-order differential equation. Kasi y raised to 0 is equal to 1, so the right-hand side will just be q as a function of x. So we can solve this type of equation using the previous lesson or method that we've discussed. If n is equal to 1, the equation can be written as derivative of y with respect to x plus p of xy equals q of x times y. Then pagsamasamahin natin lahat ng may y sa right hand side. Then factoring out y, we can write derivative of y with respect to x equals q as a function of x minus p as a function of x, all multiplied by y. We can see that this reduces to a variable separable differential equation. Kaya ang i-consider natin for this topic is all values of n that is not equal to 0 or not equal to 1. Let us derive the method of solution for a Bernoulli differential equation. Let's start by dividing the whole equation by y raised to n, where that is the same by multiplying the whole equation by y raised to negative n. Distributing y raised to negative n, we'll get derivative of y with respect to x times y raised to negative n plus p as a function of x, then y, add lang natin yung exponent, we have here 1 minus n equals q as a function of x, then y raised to n minus n, that is y raised to 0, so that is equal to 1. Hindi natin susulat dito. Next, let us introduce a new variable z such that it is equal to this term, y raised to 1 minus n. Taking the derivative of this equation, derivative of z is equal to, using power rule, 1 minus 1 multiplied by y raised to 1 minus n, minus tayo ng 1, derivative of y. Simplify lang natin yung exponent and we'll get derivative of z is equal to 1 minus n multiplied by y raised to negative n dy. We can see that this term is equal to this. So divide lang natin yung buong equation by 1 minus n and we can solve an expression for y raised to negative n dy. Palit natin ngayon itong value na to for y raised to negative n dy dito. In the same way, palitan na rin natin si y raised to 1 minus n with z. We'll get 1 over 1 minus n multiplied by the derivative of z with respect to x plus p as a function of x multiplied by z equals q as a function of x. Then, tanggalin natin to. Parang matira na lang sa first term is derivative of z with respect to x. We can do that by multiplying the whole equation by 1 minus n. And we'll get derivative of z with respect to x plus 1 minus n multiplied by p as a function of x times z equals 1 minus n multiplied by q as a function of x. Take note that n is a constant. We can see here na na-reduce natin yung Bernoulli differential equation sa isang linear na differential equation, wherein this new term is yung parang p of x natin, tawagin nating p bar of x, and this term is q of x. Recall lang natin, previously, ang solution sa isang linear differential equation of the form na derivative of y with respect to x plus p of x times y equals q of x. O hinahanap natin muna si integrating factor. Equal yan sa e raised to integral of p of x dx. Then ang general solution, integrating factor multiplied by the dependent variable y minus integrating factor multiplied by q as a function of x dx equals a constant. Apply natin yung same formula na to sa ating Bernoulli equation. Yung bago nating p, tawagin nating p bar of x is equal to 1 minus n p of x. Yung bago nating q is 1 minus n multiplied by q of x. Pansinin ninyo na multiply lang yung p of x and q of x sa 1 minus n. The new integrating factor is equal to e raised to the integral of p bar of x dx. And the general solution is now the integrating factor. Kopyahin lang natin to. multiplied by the dependent variable. Take note, dahil nagpalit tayo ng variable, ang dependent variable na natin is z, which is equal to y raised to 1 minus n. Lagay ko muna dito z minus the integral of the integrating factor multiplied by the new u bar of x dx equals a constant. Then, palitan lang natin ang value sa z. Integrating factor multiplied by y raised to 1 minus n minus the integrating factor multiplied by q bar of x dx equals c. Halos pareho lang to sa general solution ng isang linear differential equation except that napalitan yung ating dependent variable that is expressed in terms of y raised to 1 minus n and yung q of x natin na multiplied by 1 minus n. In the same way, yung p na ginagamit natin to get the integrating factor is also multiplied by 1 minus n. Solve tayo ng sample problems to see how this works. Problem number 1. Y prime equals y minus xy cubed e raised to negative 2x. Paano ba madaling ma-recognize yung Bernoulli differential equation? Let's say ang ating dependent variable is y. Kapag nakakita kayo ng terms containing y raised to first power, tapos yung other term is meron ding y, pero yung power niya is different. Isang sign na yon na yung differential equation mo is Bernoulli. Sulat natin si y prime in terms of derivative of y with respect to x. This is equal to y minus x y cubed e raised to negative 2x. Then, lipat natin si y sa left-hand side para maisulat natin siya sa standard form. Derivative of y with respect to x minus y equals negative x y cubed e raised to negative 2x. Multiply natin yung buong equation by y raised to negative 3 para matanggal natin to. We'll get y raised to negative 3, derivative of y with respect to x, minus y, 1 plus exponent nung another y, that is negative 3, equals negative x, e raised to negative 2x, kasi makakancel na yung y term. Simplify lang natin to. Y raised to negative 2 equals negative x, e raised to negative 2x. Introduce tayo ng another variable. Tawagin natin siyang u. Then equate natin siya with this term, y raised to negative 2. Taking the derivative of this equation, we'll get derivative of u equals negative 2, y raised to negative 3 dy. Then solving for this, kasi equal lang yun dito, we'll get du over negative 2 is equal to y raised to negative 3 dy. Substituting this for this, we'll get 1 over negative 2, derivative of u with respect to x, minus, palitan natin si y raised to negative 2 ng u, equals negative x, e raised to negative 2x. Then, tanggalin natin to by multiplying the whole equation by negative 2. Derivative of u with respect to x plus 2u equals 2x e raised to negative 2x. You can see na na-reduce na natin yung Bernoulli differential equation into a linear differential equation wherein yung ating p as a function of x, that is 2. Lagyan natin ng bar kasi Bernoulli differential equation na to. And yung ating q as a function of x is yung nasa right side. Solving this, we need the integrating factor that is just equal to e raised to the integral of this term. Sub lang natin C2 for the value of p bar of x. And simplifying this, we'll get e raised to 2x. The general solution for a linear differential equation is the integrating factor multiplied by the dependent variable. In this case, u na yung dependent variable natin minus the integrating factor multiplied by u as a function of x dx equal to a constant. Palit natin to, e raised to 2x multiplied by u, that is y raised to negative 2, minus the integral of e raised to 2x multiplied by q as a function of x, 2x e raised to negative 2x dx equals c. We'll have here e raised to 2x over y squared minus, we can cancel this term kasi magiging 1 lang siya. Then ang matitira is 2x dx equals c. Solving for the integral of this, that is equal to x squared over 2 equals a constant. We can cancel 2. Then, para matanggal natin itong denominator, multiply lang natin yung buong equation by y squared. And finally, we'll get the general solution as e raised to 2x minus x squared y squared equals c y squared. Or we can also combine all the terms containing y squared on the right hand side. We'll get e raised to 2x equals c plus x squared quantity y squared. Problem number 2, 2x cubed y prime equals y quantity y squared plus 3x squared. Sulat muna natin si y prime as derivative of y with respect to x. Then expand natin yung right hand side, y cubed plus 3x squared y. Sulat natin to as derivative of y with respect to x. So divide natin yung buong equation by 2x cubed. We'll get derivative of y with respect to x equals y cubed over 2x cubed plus 3x squared y over 2x cubed. Simplify natin to. We can divide this. Matitira na lang is x sa baba. Then, i-move natin to sa left hand side. We can see na naisulat na natin to sa standard form ng isang Bernoulli equation. Divide natin yung whole equation by y cubed para ang matira na lang sa right hand side is a function of x. And that's the same with multiplying the whole equation by y raised to negative 3. And we'll get y raised to negative 3, derivative of y with respect to x minus 3 over 2x. For y, 1 plus negative 3, that is y raised to negative 2 equals, this can be cancelled. Ang nasa right side na lang is 1 over 2x cubed. Then, introducing a new variable, let's say that is z. Equate natin siya dito para ma-reduce natin yung Bernoulli equation to a linear differential equation. Then, taking the derivative of both sides, negative 2 y raised to negative 3 dy. Then, solving for this term, derivative of z over negative 2 equals y raised to negative 3 dy. Palit natin to for this. 1 over negative 2 times derivative of z with respect to x minus 3 over 2x. Y raised to negative 2 is now z equals 1 over 2x cubed. Then, tanggalin natin to by multiplying the whole equation again by negative 2. We can see now na na-reduce na yung Bernoulli equation into a linear differential equation with a new dependent variable na z. Multiply lang natin to and that is positive. 3, makakancel si 2 over x multiplied by z equals negative 2 over 2, that is negative 1, kaya magiging negative yung right side natin. This is now the new p. This is the new q. Solving for the integrating factor, same lang sa ginagawa natin sa linear differential equation. Subbing the value for p, that is 3 over x dx. Solving for this integral, that is e raised to 3 ln of x. Then we can make 3 as the exponent of x. Simplifying this further, that is just x cubed. Solving for the general solution, we'll multiply the integrating factor by the dependent variable z minus the integral of the integrating factor multiplied by q bar of x, negative 1 over x cubed dx equals c. Palitan na natin si z ng y raised to negative 2. Then, simplifying this, we'll get negative 1 dx equals c. This can be written as x cubed over y squared. Then, negative times negative 1 is positive. Integral of dx is x equals c. To remove the denominator, we'll multiply the whole equation by y squared. And we'll get x cubed plus xy squared equals cy squared. And pagsamasamahin lang natin lahat ng may y squared sa right hand side, that is equal to x cubed equals quantity c minus x multiplied by y squared. Problem number 3, quantity y to the fourth minus 2xy dx plus 3x squared dy equals 0. I-write natin to such that maisusulat natin siya in a standard form ng Bernoulli differential equation. Divide natin yung buong equation by dx and 3x squared. From that, we'll get y to the fourth minus 2xy all over 3x squared plus derivative of y with respect to x equals 0. Then, unahin na natin isulat to. For the second term, pwede natin itong isulat as 2 fractions. Y to the fourth over 3x squared minus 2xy over 3x squared equals 0. Simplifying this, we can divide x. Ang matitira na lang dito sa baba is 3x. Lipat natin si y to the 4th over 3x squared sa right hand side. And we'll get derivative of y with respect to x minus 2y over 3x equals negative y to the 4th over 3x squared. Ang standard equation ng Bernoulli differential equation is derivative of y with respect to x plus p of x times y equals q of x times y raised to n. Nakita natin sa mga previous solution na yung bagong value ng p is just equal to 1 minus n multiplied by the original p, and for the new q, that is the same, multiply lang natin by 1 minus n yung dating q. Identify natin ngayon ano ba yung value ng n for this differential equation. We can see that that is 4. And the value of 1 minus n is equal to negative 3. Multiply natin ngayon by negative 3 yung original p of x natin, that is negative 2 over 3x. Simplifying this, negative times negative, that is positive 2 over x. For the new q, again that is negative 3 multiplied by the old q, negative 1 over 3x squared. Simplify. Then this will become positive 1 over x squared. The integrating factor is equal to e raised to the integral of p bar of x dx. Palit natin dito yung bagong p, that is 2 over x dx. This is equal to e raised to 2 ln of x. Then gawin natin exponent si 2. Simplifying this, that is just a term inside ln. And the general solution is that is equal to the integrating factor multiplied by the new dependent variable, that is y raised to 1 minus n, minus the integral of the integrating factor multiplied by q bar as a function of x dx equals c. The integrating factor is x squared multiplied by y raised to 1 minus n is negative 3 minus the integral of x squared multiplied by the new q 1 over x squared dx equals c. This can be written as x squared over y cubed. This is x squared is cancelled, so the second term is just the integral of dx, or that is x, equals c. Simplifying this by multiplying the whole equation by y cubed, this is now equal to x squared minus xy cubed equals cy cubed. Then writing all the terms containing y cubed on the right hand side, we have x squared equals quantity c plus x multiplied by y cubed. Problem number 4, 2y dx plus x times quantity x squared ln of y minus 1 dy equals 0. Sulat natin ulit ito na ang dependent variable is y. Kaya divide natin yung buong equation by dx and itong kasama ni dy. Doing this, we'll get 2y all over, expand ko na to, x cubed ln of y minus x squared plus, this is cancelled, derivative of y with respect to x equals 0. Then, pwede ba natin itong isulat as 2 fractions, gaya nito? Tandaan ninyo, kapag may more than one term ka sa denominator, wag nyo siyang isusulat as 2 fractions. Illegal yun. This is not equal to this. Check natin ngayon ito, kung siya ba ay Bernoulli differential equation. Since hindi natin ito mapag-iwalay, we can notice na hindi nga siya Bernoulli differential equation. Instead, gawin nating dependent variable si x. Divide natin yung buong equation by dy. And the term na kasama ni dx, that is 2y. Performing this, ang makukuha natin is derivative of x with respect to y plus, distribute ko na to, x cubed ln of y minus x divided by 2y equals 0. Pwede natin itong pag-iwalayin ngayon kasi isang term lang naman yung meron dun sa denominator natin. X cubed ln of y all over 2y minus x over 2y equals 0. Then, lipat ko na to dun sa kabilang side. Derivative of x with respect to y minus x over 2y is equal to negative x cubed ln of y all over 2y. Dahil sa x na yung ating bagong dependent variable, ulat natin yung dapat na standard form niya. Derivative of x with respect to y plus p as a function of y multiplied by x equals q sa function of y multiplied by x raised to n. Identify natin ngayon ano yung value ng n for this. We can see that that is 3. And 1 minus n is equal to negative 2. We now need to solve for the new y. That is 1 minus n p as a function of y. Notice na kapag nag-interchange yung dependent variable, pagpapalitin lang din natin yung x and y. Negative 2 multiplied by p as a function of y is negative 1 over 2y. This becomes positive 1 over y. And the new q is equal to 1 minus n multiplied by q as a function of y. Negative 2 times negative ln of y over 2y. This becomes positive ln of y over y. Solving for the integrating factor, that is e raised to the integral of the new p function of y dy. This is equal to e raised to the integral of 1 over y dy. Simply, this is just ln of y. And simplifying this further, that is y. The general solution, kapag x na yung dependent variable, is that is equal to the integrating factor multiplied by the dependent variable x raised to 1 minus n minus the integral of the integrating factor multiplied by q as a function of y dy equals c. Take note na in-interchange lang natin si x and si y. Palit natin ngayon yung integrating factor, that is y multiplied by x raised to negative 2 minus y multiplied by ln of y over y dy equals c. Cancel natin si y for this. Then rewrite natin si first term as y over x squared minus the integral of ln y equals c. How can we now solve for the integral of this? Let us try to use integration by parts. Set natin cu as ln of y, then dv is equal to dy. Let us solve for the derivative of this. Du is equal to derivative of y over y, and the integral of this is v equals y over x squared minus quantity uv y ln of y minus the integral of v du. Y over y is just 1, so ang matitira lang dito is dy equals c. Distribute natin to and kunin na rin natin to. Y over x squared minus y ln of y. Negative times negative is positive. Integral of dy is just y equals c. Then multiplying the whole equation by x squared, we'll now get y minus x squared y ln of y plus x squared y equals c x squared. In summary, to solve for Bernoulli differential equations, ang first step is to write it in its standard form. Second is to reduce it to a linear differential equation by introducing a new variable. Yung new variable na yun, siya na yung magiging bagong dependent variable, and from that, we have derived the general solution in this form. And we can now solve for the integrating factor, then plug in lang natin to sa general solution and solve for the integral of the remaining term. Yun lang, galingan nyo palagi at huwag kakalimutang maging mabuti. Paalam!